All right, I think we're recording. I think we're live here. All right, so we're going to get into sketching now. And like I said, this is the most important part of SolidWorks. In fact, we probably ought to spend 2 or 3 lectures on this, but because of limited time, we're just going to do one. We may bleed into tomorrow. If you can follow along, it would be helpful. So if you're logged in, that's great. If you're not logged in, maybe you could sit next to the person next to you that is logged in. If not, go ahead and just watch on the screen. But if you can log in, it'd be best. I'm going to open up a new part with my template just for fun. Oh no! Did I save over my template? Oh, that's terrible. No. Bad. Oh, jeez. Thank you. Okay. You see all this weird stuff my video card's doing? Look at that. It can't keep up. All right. I'm going to open a part. So SolidWorks, before we get into sketching, SolidWorks it's feature-based modeling. So you're going to sketch something, and then you're going to extrude it up. So, for example, if you look at my feature manager design tree, I'll call that feature tree in the future. The first thing I did was I made this little sketch here, and if I click the sketch and edit it, that opens it, and you can see what I did. I made this little rectangle, okay? And then I used and when you're done with the sketch, you can either close it out or you can close it and accept it. That's this button here. And then I extruded it using this feature, extruded boss base. So I took that rectangle and I just extruded it up into a rectangular prism. So that's what they mean when they say feature-based modeling. Okay, you're sketching and then you're making a feature off that sketch. There's different types. So you can have extrusions, which is what I just did here. You can have extruded cuts. Okay, this here is called a boss because it's raised out. This inside here would be called a cavity because it's hollowed out. There's other types of things you can do. Once you've made the base extrusion or the base feature, you can take SolidWorks has some common tools such as, let's say, filleting. So you can take a fillet and you can take an edge and fillet the edge. Sometimes it shows you this cool little preview of what it will look like before you accept it. So here I had a 0.1 inch radius fillet, and it's showing me a little preview, which is kind of cool. Then I can accept it, click the OK and accept it, and I've got this cool little fillet. So there's all different kinds of features. You can sweep, you can loft, you can revolve, you can make holes, you can make cuts, revolved bosses and bases, ribs and drafts. You can pattern things, you can fillet things and chamfer things. Again, I would encourage you to go through all these little goofy picture options and kind of hover over it until you see the words and read what the words mean. And just familiarize yourself with the types of options you have there. Okay, the other thing about SolidWorks is it's historical. All right, and so what does historical mean? So it goes in order. So you can tell what I did based on the order in this feature tree. So the first sketch I made was that rectangle, and then I extruded it. Okay. The next thing I made was a sketch of all those little pegs, the 8 little pegs. Then I extruded those. Okay. Then I made a sketch of, looks to be that inside rectangle in here. And then I cut that. Then I made a sketch of these little holes here, and I extruded those. And then I just added that fillet you saw. Now this matters a lot. The historical nature matters a lot. And I'll go back to math order of operations. Oh, of course there's no marker. I'll do it on the screen. Will you write down a note to get us some markers? All right, so let's go back to math. Same answer? All depends on the order I did it in, right? So SolidWorks is the same thing. Sometimes it makes sense to do it this way. Sometimes it makes sense to do it this way. But realize that you're going to get a different result each way. So I can give you, let's open up another Lego that I did in a different order. I think it's this one. Yeah, it's this one. So I kind of did this one. I didn't finish it and make it exactly like the other one, but I made this up as an example. In this particular case, the way I did this is probably a little smarter than the way I did the other one. Same result. It's the same model, but it's smarter, quicker, cleaner. Okay? And the way I did it was started with the same rectangle, extruded it. Then started with one of these little guys and extruded him, right? So I just made one of these, whereas in the other one, I made all 8 in my sketch. In this one, I just made 1 in the sketch. I extruded him, and then I patterned him. So I did this linear pattern deal here. Now, in order to get that pattern done correctly, I had to put some other stuff in there. So I had to put a different coordinate system and a different sketch plane, and we'll go into that kind of stuff later. And then I went and did the fillet, and then when I did that linear pattern, all 8 came up all the same. Whereas over here, I would have to fillet each one of them. Which you can do. It's another way to do it. And again, this is this is a silly example, and it was probably just as quick to do that as it was to do the other. But when your models get much more complex, you're probably going to want to attack the problem differently. Okay? It's important in SolidWorks to, just like in coding, like you probably haven't done much software programming yet, but in coding, it's really important to sit down and write out your structure and your architecture before you open up the utility and start coding. You want to get a good structure going. You want to have a plan of attack for your parts. And we'll get into that a little bit more later. That's called design intent. They call that design intent, is your plan of attack for your part. And it really matters. What you'll find out, you're going to do this anyway, you'll learn the hard way. What you'll find out is you'll make this crazy model that you spent 2 days putting together, big assembly with a bunch of parts in it, and then you're going to want to make one little change, and it's going to screw everything else up. And you're going to either have to start over from scratch, or you're going to have to go back and fix all the errors in your model. If at the start you had thought, hey, what about this model could I potentially want to change later? It's 5 inches now, but would I ever change that 5 inches? If the answer is yes, you might want to think, okay, I better design in a strategy such that I can change that width or that length or that hole, and it doesn't jack up the whole model. Okay? So you should be thinking about that when you're making a part, an assembly, or other parts. All right. That's also called parametric design. So your designs are based on certain parameters, if you change the parameter, it changes everything. So for example, if I go in here and I right click edit this sketch, and I take this Lego and I change it from 2.5 inches to 10 inches, okay, 10 inches wide, what do you think is going to happen? The holes are probably going to stay in the same place, and I'm going to have this weird looking, so I'm going to accept that dimension change, accept that sketch, and SolidWorks is going to rebuild, okay, and it said, check it out, it put all my 4 little Lego things over here, when maybe that's okay, maybe that's what I wanted, but maybe I wanted the 4 holes to stay the same and to distribute themselves evenly over that length, okay. You can do that, but you have to design in a way to do that. It has to know to adapt that way when it rebuilds. Okay, maybe I didn't want that at all. Maybe when I did 10, maybe I wanted it to drop in pegs, enough pegs that'll fit into all of it. You can do that too. There's all kinds of things you can do with SolidWorks, but you have to stop and think, what do I want to do, and what do I want to make, and how do I want my model to react? Now, it didn't like something. This is interesting. I was going to bring this up later. I'm not sure what it doesn't like, but let's figure out what it doesn't like. It says Boss Extrude 3, which I can go back here and check out, has an error. So let's hit stop and repair. And sometimes this is a helpful dialog, and sometimes it isn't. So it's telling me Boss Extrude 3, the sketch has intersecting contours. Okay, so I can, and you see how this turned red? And then the whole part turned red. All right. When it has an error, it'll throw you that. You can still do stuff with it, but it'll tell you you've got a rebuild error that causes it to freak out. So if you go back into the sketch, you might be able to see what's wrong. It looks to me like, what is it not liking? Oh, it's the 3 holes on the back side. See those? Look what it did to me. So it kept that little pocket centered within the part, but it didn't keep these centered within the part. And that has to be because of the way I defined the cut extrude sketch here. I did that. I must have done that with relations rather than with dimensions, and we're going to go into that next. So, and then it doesn't like the 3 cut extrude circles, the 3 little guys that we're going to do in there. Now, there is a way in here sometimes to ask it for help. It's usually down in here. Let's hit rebuild, and it's not going to like it, but down towards the right, let me get rid of this guy. Sometimes it has a it'll make suggestions on what would fix the error. I think we'll do that in the next section. Yeah, let's do that next. So I'm going to close out of this. But this is a perfect example of design intent. If you wanted to be able to change that length and you wanted these things to stay evenly distributed, you'd have to force them to do that. Yeah.
Did you change the linear symmetry one, or did you change the first one that you made?
So this was the first one. So yeah, we can go to the symmetry one. So this is the linear pattern one, and I believe I did the linear pattern off midpoints of whatever this rectangle is. I think I did. So if we increase this, it should evenly distribute them. What the heck? Let's try it. Let's do the same thing. "10 inches, select the check mark, check that, accept my sketch, it'll automatically rebuild." Nope. Didn't freak out, didn't have an error, but it didn't stay centered either. Okay, so again, if I had really cared about that, I should have designed that in. Now there's lots of parts you're not going to care, so why bother? Don't make this really difficult algorithm if it's never going to change, right? But if it is going to change, you want to take the time and think about what about the model would change. Maybe the width stays the same, but the length changes. Maybe the number of holes I want to put in it changes. Maybe the size of the holes changes. So think about that. Okay, let's move on. All right. So that was just to show you design intent. I just want to have that in the back of your mind. Let's start from the beginning. Everything starts with a sketch. So you go up to this command manager and your sketch tools. You guys can follow along if you want. And then you can hit sketch. Now, there's more than one way to do it. So I just clicked sketch. You don't have to do it that way. You can go to these planes and you can right click and hit a sketch. Or you can just hit sketch and pick a plane. Doesn't really matter. SolidWorks is kind of this free-flowing deal. You can pick whatever plane you want. In this case, I'll just do top. What the heck? Let's do top. You notice how it kind of moved it so that your perspective is normal to that plane. And then it centered the axes in the window. You can tell you're in a sketch because you see this little sketch symbol up here. You can also tell because you're down here and it says editing sketch 1. You can also tell because it says up here sketch 1 of part 3. And you can also tell in your feature manager because it says sketch 1 right here. This is called the rollback bar. So everything above this bar has been rebuilt by SolidWorks. Everything below it is kind of in progress. All right. SolidWorks will force, if you have an error way down the line, it'll force that rollback bar way back up to where the error is. Kind of helps you determine where the error is and what sketch and what feature is causing an error. All right, so here's an open sketch. All right, let's see. What do I want to do? Really important, and it's going to become critical later, is relations in the sketch. So here are all your sketch tools. Lines, circles, splines, ellipses, all kinds of jazz. And under each one, there's a little drop down, and you have different kinds of lines, different kinds of circles, different kinds of rectangles, that sort of thing. All right, just for fun, I'm going to sketch some lines up. So I'm just going to pick the line tool, and I'm going to start at the origin. Now, by starting at the origin, I'm going to click that, and then I'm going to just pull this line out. You can see it's making a dimension for me. And then I'm going to start pulling around. Now look what it does. SolidWorks does what's called snaps. All right, it's trying to guess what you want as you're dragging. So right there, look, it made that line. Look at the little perpendicular symbol on the bottom right of my pencil. That snap made this line perpendicular to the first line I drew. Okay, and then I pulled down a little bit and it made it collinear or horizontal with the midpoint of the first line I drew. So SolidWorks is trying to figure out what the hell I want here. So let's just pick this one parallel, and then I'm going to pull another one, and let's pull that like that. So I've got this one's probably going to be linear, and then I'll just complete this four-sided figure. And then I'm pulling around here, but I'm done with lines, so I'm just going to hit the escape key, and that gets me out. Okay. Now the first thing we're going to notice is the color of the lines. They're blue. If a line is blue, that means it's underdefined, which means I can move it around. I can click and drag it around. But before I click and drag it around, I want you to see the relations that the automatic snaps did. So you can go up to, it's under the sketch toolbar, and hit display delete relations. Okay, and here's your little display delete relations property manager. And if you look at it, all the relations that it did with those snaps is it made a perpendicular. See this perpendicular one? And you can see it here. It's blue. Made a little perpendicular symbol. So that little guy's perpendicular. And then it made a coincident here. And that, I believe, is going to be coincident with the origin. Okay? This is critical. Knowing what relations are going on in your model determines how it's going to behave when you start making changes. So if something's not going the way you think it should be going, go back to the sketch you're in and hit your display relations and say, oh, SolidWorks thinks this thing has to be perpendicular. It doesn't have to be perpendicular. Delete that relation. Okay? For right now, I'm going to keep these relations and I'm going to show you what they do. So let's say I grab this little guy and I want to, oh, I hope this works with this. Yeah. So I held the line and I'm dragging it and I'm just moving this model around. But look what's not moving. See the little green perpendicular? It's not letting me change it. Why? Because it's locked. It's a perpendicular relation. SolidWorks thinks I really want that. You got to have that, buddy. So you can move this around, but I'm not going to let you move it around anymore. All right? So all of these lines are underdefined. I can move them around, but I can only move them around based on the rules that have been set. And so far, the only two rules that have been set are perpendicular 1 and coincident 0. Okay? So I shouldn't be able to drag this point around, and I can't. But I should be able to drag this point around. See that? Getting all jiggy with it. All right? I can move this point because there's no coincident relation, but it's going to maintain the perpendicular. See that? I'm wigging it all over the place, but that angle stays 90. You see it? All right, so all four of these lines are underdefined because they can be moved. All four of them can be moved right now, subject to those rules. So let's delete one of them. Let's take that perpendicular out. Right-click, delete. Now I should be able to move this guy. Oops, I drug that line. Now I should be able to move him. Oh yeah, see? Now he's flexible. All right? But all four of my lines are still blue, which means they're underdefined, which means I can move them around. Let's start adding some rules. So one way to add a rule is to dimension your part. So go to Smart Dimension. You can either click the Smart Dimension button or you can look at all the different kinds of dimensions. Okay, I'm just going to click a Smart Dimension and I'm going to click the line. And again, SolidWorks tries to guess what you meant. Did you mean the vertical distance from that point to that point? Did you mean the length of that line? Did you mean the horizontal distance? So as you drag the mouse around, it kind of tries to guess what you want. I'm gonna call it this 2.21, and let's just call it something normal, so it's 2 inches, and then I'll accept that dimension. Okay, they're still all blue, which means there's not enough rules. I can still drag this thing around, but what can I not drag around? I won't be able to change that 2 inches. So if I try and change this point, I can move them around, but see how that length stays 2 inches? That's a rule. All right, let's try another one. Let's try Smart Dimension, and let's try an angle. So I'm going to click this line, and SolidWorks guesses I care about that angle, or this angle, or that angle as I drag around. Let's say I care about this angle. 75 degrees. All right, there we go. Still, all four lines underdefined, but guarantee I can't kill that angle. See that? I'm losing degrees of freedom on my drag here because of the rules I'm instituting. All right? Sooner or later, we're going to be able to add a rule that is going to freeze something in here. Now, if you really thought about it, you probably could just figure out the least amount of rules you could to make all four lines stuck. And I'll show you that in a second. Let's try making a different type of rule. Instead of dimensioning it, let's try making a relation rule. Okay, so let's add a relation. So I went to my display delete relations and I hit add relation. All right, so let's say we can add all kinds of relations. Let's say I take this line and I want to, so if I just selected that line, it tells me what I can do based on all the rules that are already there. So in this case, I can make it horizontal, vertical, or I can fix it. I can just say, don't move, stay in space. Let's call it horizontal. And I select that. I'm still all blue because I don't have enough rules to force these lines into place. But watch my degrees of freedom. I'm going to have trouble moving things now. So I can move this guy. My 75 angle maintains. My horizontal line maintains. And my 2-inch length maintains. See my 2-inch, my 75, and my horizontal. Okay? We're getting close. I add one more thing, and we're probably going to lock something into place. Let's try adding another relation. Let's say this guy and this guy need to be, now look, so I selected the two lines. Now I've got horizontal, vertical, collinear, so that'll force them to snap into the same line. I can do perpendicular. Parallel is going to be a little goofy. That's interesting. I don't know if that would work. I can make them equal length, or I can fix them in space. Let's try perpendicular. I really want to try parallel because I don't see how they can. You know what that's probably going to do is force that point. Let's do it. Pretty goofy. So I'm going to go back to perpendicular. And I just went to perpendicular and it called me overdefined. It showed me red. It says overdefined down here in red. It says the sketch is overdefined and you can click here to resolve it. Now we know what the answer is. We're going to have to, you can't be perpendicular and parallel at the same time, right? But just for fun, let's go down here and see if it'll tell us. So I clicked overdefined and I can hit diagnose. And it's going to give me all the options that it can think of that will fix this problem. Here's showing option 1 of 2. It says get rid of this perpendicular. Or option 2, get rid of this parallel. Okay, so I'm going to go ahead and accept getting rid of this parallel. And I hit accept. The sketch can now find a valid solution. Green check. And I've got that if I display this display relations, I've got that perpendicular right there. I've got that angle, got that distance. I've got that coincident at the origin, my perpendicular, and my horizontal. See it right there? Alright, so I wanted to show you that diagnostic tool because that can help you a lot, especially when your models get really crazy. So I'm still not stuck. Look what I can do. My 75 is the same, my 2 inches is the same, my perpendicular is the same, my horizontal is the same. We got to get this thing to stop. So let's throw another dimension in. Let's throw this guy. How about that? Let's make him 3.75. Still not black. I'm still underdefined everywhere. I still can move all over the place. So all my guys can move. Let's put one more in there. Let's force this angle. There we go. I put so many rules in that all 4 of my sides, just with that one angle, got locked into place. You can tell that they're black. They're fully defined. I can't move them. Can't click and drag them. They're stuck. Okay? If you want to be able to move them, you're going to have to start eliminating rules. Enough rules that you can move those around. Okay? Now you can build off of this and you can extrude off of this without it being fully defined. So I can go to display delete relations and I can delete all the rules are gone. It's blue. And I can go ahead and extrude it. Let's say I want to go 1 inch. Select that. And green check mark, and I've got this thing. Okay? But this guy is underdefined. All those lines are blue. So I can twist and shout this guy. I can move him around and do all kinds of crazy stuff with him. When I start cutting holes in it and when I start changing dimensions, it's going to radically change this thing. If it was fully defined, I could change a dimension or I could change a relation, but all the other dimensions and relations are going to have to jive with that rule that I just put in place. Make sense? Questions? This is a really important part of SolidWorks. It's basically the fundamentals of the entire thing. When you start having problems with your models, it's going to be because of this, I can guarantee you. It's going to be your relations or your dimensioning rules. Those are going to be your problems. So look there first. All right. Let's walk through one together real quick. I'm going to do a new part. All right, so I just want to play with a rectangle. So I'm going to go to rectangle. I'm going to pick the front plane this time just for fun. It didn't automatically put my view normal to that. That's okay because I want to show you. I'm going to go ahead and start this at the origin, which is going to force a coincident relation there. And then I'm going to pull this rectangle. And I'm going to hit escape. And then I'm going to go up here to our heads-up display. Remember that heads-up toolbar? Let's take a look at view orientation. So I can do some crazy view orientations. I can do the top and the bottom and the front. The most important one that I use all the time is this normal to one. So that's normal to the plane that it was created on. So that's very useful so that you can look at the plane that you created your sketch on. You can change the display styles. I'll do that in a minute. Notice that 2 of these lines are black, which means they're fully defined, which means I can't really change them. Why did that happen? I didn't even type in any dimensions. Go to your display, delete relations. Here's the relations it came up with by just snapping. It said, okay, you wanted this to be horizontal. You wanted this to be horizontal. Vertical. Vertical. Coincident with the origin. Okay, whatever. I'm fine with that. Just wanted a rectangle. I'm going to dimension this guy. Let's call him 2 inches. Accept the dimension. Accept the sketch. Did you see how, I'm going to go back to the sketch and edit it. See how that dimension locked that line in now? Because, let's see, there was 2 verticals, a horizontal, and then once I dimension it, that makes it so that you wouldn't be able to, what can we move? We can move this guy, but we can't. Once he's dimensioned, once that line is that length, and he's horizontal, we can't move him. Okay, and to fully define this, what would I do?
Define the height.
Correct. So if I just put a dimension in there and make him 1, there's no way I can move anything else with the rules I have in place. Okay? All right, let's extrude it. So I finish the sketch and I get out of it. I go to my features, extrude it. It's going to guess that I want to, hey, you turd. Let's go back to the sketch and extrude him. So did you see what just happened? It didn't know I meant that sketch. So it was asking me, what do you want to extrude? So I had to go back to that sketch, click the sketch, and then tell it to extrude it. There's different options in here. So you can do up to a vertex or a surface. You can, with this little button, I can change the direction. Do you see this little arrow here? It's going that way. I can make it go the other way. That becomes important later when you start drawing parts in assemblies. The distance I'm going to make it shows me there. I'm going to do a 1/2 inch. You can kind of loft it within here if you wanted to. We'll go into that later. And then I'm going to accept what I have here. All right. Now, what can we do here? Well, we can use a little roller wheel and we can spin this thing around. We can play with the display states, so I can look at different facets. I can select this face and I can say get me normal to this face. So there we are there. I can play with these display states. So this is solid with edges defined, so you can see the edges. This is solid with no edges, so you see there's no little black lines there. Then I can do solid with not shaded with hidden lines removed. I can do with hidden lines, so hidden lines are dotted, and I can make those hidden lines solid. This is really useful when you're trying to look at things, especially when you pile 10 parts onto each other. All right, so the different display states. You've got your zoom to fit, You've got your zoom in. You can use your roller wheel. You can change your appearances. So you can change your colors. So we can make this thing fuchsia. You can change not only the color but the appearance. You can make it mirror, or, crazy, or different material, make it look crazy. This goes back in, you can put textures in. So this goes back to your style stuff. Start thinking about your checkered. So let's just leave it checkered. This is where you can be stylistic with your parts. So play with that. Visibility. I can go to my feature here, and I can make it. I can hide it. Okay. I can show it. I can edit its sketch if I wanted to change its dimensions. I can suppress it. So it's gone. It's not highlighted. It's kind of grayed out, but it's still there. Everything I wanted is still there. It just doesn't have anything to do with the model we're dealing with. That's a very useful feature. Then I can unsuppress it. It's back. What else do we have? Again, in your right-click menu, you've got appearances. You can go normal to, zoom, suppress, rollback. You can do all that stuff. You can also rebuild it. Here's the little stoplight. That'll rebuild your model based on the changes you've made. If you made a change and it's not rebuilt, it'll make a little stoplight right in front of it. We'll probably see that later. All right. Yep.
If you're making a design with a ton of different parts, would
Yep.
you suppress the part and then build a new part, or would you build each part individually, save them all, and then import them into a single document?
There's a lot of different ways to do that, and they all react differently. So you could you can build 10 different parts, and then you can insert them into an assembly. You can build a part, make an assembly, insert that part, and then build the other 9 parts in that assembly. And then they will all save as 9 distinct parts, and they all save as in the same assembly. So that's one of the benefits and the drawbacks to SolidWorks is it's so freeform and so open. There's 10, 15 infinite different ways to do the same thing. Okay, so it all comes back to design intent. What did you intend for the thing involved? An instance where it would make sense to make a part and then make a separate assembly and then insert the part into the assembly is if you wanted 20 of the same part in that assembly. Why build 20 parts in one assembly? Build one part and just click them into the assembly. So you can do it. There's a lot of different answers for that question. Look at my poor graphics card. Freaking out. Okay, 10 more minutes. We probably won't get through this, but that's okay because this is important stuff. We'll continue tomorrow. Let's try design intent again. We're going to do a little exercise. So I'm going to go back to my rectangle part. And I'm going to make a random rectangle. I'm going to view normal so I can see right up against it. And I want to dimension it so I know how big it is. 2 inches and 1 inch. Yeah, go away. Okay, and then I'm going to extrude it. Go to features, extrude it, 1/2 inch. Okay, what if I want to make another feature on this feature? So what I want to do here is I want to cut a hole in it. Alright? If you want a hole, you have to have a sketch. Everything starts with a sketch. Alright? So a hole would be what kind of shape on the sketch? A circle. So, and I want it on this face, not this face. I want it on this face. So I select this face, and I'm going to hit sketch. And it's going to open up a new sketch on this face. Check it out. It's below the rollback bar. And it's got a little stoplight because it's not rebuilt yet. I just started it. Alright. I'm going to make this normal to. And I'm going to go to my sketch toolbar and make a circle. and click it, and then I'm going to cut this. All right, but before I cut it, let's put it in the middle. All right, so I'm going to go to dimension. Here's my center. I'm going to click the center and this line over here, and it guesses I want this dimension from the left side to the center. This was 2 inches, so I'm going to make it 1 inch. Okay, cool. Now I want to center it in the other dimension, so I'm going to go this one and this one, right? And this was 1 inch, so I'm going to make this a 1/2 inch. All right, centered, right? It's right where I want it. I'm going to exit my sketch. You can see that little sketch there. See, sketch 2. If you open up Boss Extrude 1, which is this big rectangular prism, you can see my original sketch, and here's my second sketch. All right, so I click my second sketch so it knows what I'm talking about, and I go to my features, and I go to extruded cut. Now I want to cut it. Well, I don't want to go blind. So, well, maybe I do. If I wanted to go blind, I could go, let's say I only wanted to go 1/4 inch in. I could select that and check mark, and it cut it down in there 1/4 inch. See that? All right, now I'm going to go back just for fun, and I'm going to edit the feature. So I right-click on the feature itself, edit feature. Instead of blind, I want through all, and then select it. Okay, so I've got a hole through it. Cool. Neat rectangular prism with the hole through it, centered. All right, back to design intent. I'm going to go to my rectangular sketch. I'm going to change this to 8 inches. What's going to happen? Hole's going to stay where it is. Whoops. Do I care? Did I want it there? Maybe I did want it there. Maybe there's a bearing that goes there, and it's absolutely got to be 2 inches from this side no matter what. But what if I wanted it in the center every single time, no matter what? That's the design intent. That's what you as the engineer have to think of before you draw up the part. Okay? So if I wanted that centered, what could I have done? No matter what, I want it centered all the time. Okay, use your snaps is a little vague.
Snap from, can you snap from the midpoints?
Yes, you can. But it's not just snaps. It's we need to add rules or relations from the midpoints. So if I had a rule that said, hey, this center has to be what with these two sides? What's another way of saying that? The center, let's say if we're talking about the, if we wanted to center in this dimension, this vertical dimension, the center of that circle would have to be what with the midpoints of these lines? Not coincidental, because coincidental is right on it. Co-what? Linear. All right? So if this midpoint and this midpoint are there and there, that center, in fact, I can draw them on there for you. Let's go to sketch, and then we'll open a sketch here, make it normal, fit it, and zoom in a little bit. I can sketch a little point, you'll see it better. So look, I'll put a point and see it snapped to the midpoint there. See how it says midpoint? And then I'm going to put a little center. And, oops, did it give me a point? Give me a point. Thank you. And it's coincident with what, you suppose? The center of the circle. And then it snaps to midpoint there. And now I've got those 3 points. So do you see how if those 3 points are co-linear, if they're all in the same line, then this circle, no matter what, would have to be forced to be in the center of this vertical distance, right? So I could add those relations. So let's do that. Let's go back to this sketch because that's the one in question. So we can say add relation, and you can say this point, out of my way, that point, and oh, there's no midpoint there, so I can't add a relation with that midpoint because it's not there. So what do I do if it's not there? Put it in. So we're in the sketch. We're going to take a point and we're going to snap it right on there. Thank you. I'm the midpoint. Thank you very much. I know I'm the midpoint. And now I'm going to snap this one here. Thank you very much. You're the midpoint. Now you can go to your add relations and you can say point 8, which has already got selected there. Go to that point and that point. And you could make, looks like they want to be horizontal. So you could make them horizontal. Or I don't really want that, right? I would have rather had them my delete button's not working. Clear selections. I would have rather had them collinear. Come on, I'm not getting collinear, B. Maybe. Well, I should have gotten a collinear. We'll have to look into that. But that's what we're going to play around with. We are down to 2 minutes, so we will continue with this tomorrow. But homework. Look on your calendar. Homework is here. Let's make your own drawing part templates and turn in. If you go to D2L,
You want both the drawing and a part template?